Okay, hi all. I've decided to try to put this into a lesson for you. I was going to run it as a lesson, but I'll do it today and explain everything, and I'll upload it. We'll still have a meeting. Anyway, this is a lesson about descriptive statistics, which you've been already doing. You've already worked out the mean and the median. Some of you have gone beyond and done box and whisker plots and other bits and pieces. I really just wanted to talk about the mean and the median, and then I'm going to talk about standard deviation as well. So the mean and the median are known as measures of central tendency. So it's measures of middle, but measures of central tendency sounds really good. Okay, continuing on. So I want to give you an example to talk about the mean and the median and the difference between the two. And this is a really good illustration of the difference and what conditions each one is best for. So firstly, the mean, if I decided to do an average mean of all our ages in the group, let's say everyone is 17 and then I put my age in 53. So if I work out the mean of that, okay, so in the mean we know that we add up all the numbers, and when I add up all the numbers I got 155, and then I have to divide that by 7, of course. So 155 divided by 7, the mean in this case, I'm going to put it up the top here, is equal to 22. I'll round it up to 22. So 22, is that a really good measure of the central tendency, considering when we've got such a small group of people? So sometimes the mean can have some concerns when we're talking about a small group. It means that an outlier, such as the 53, can skew results. So sometimes with these sorts of numbers, with a very small group like this, we do the median. So that means we put them all in order. 1, 2, 3, 4, 5, 6 and 53, and then we take the middle number. Now the middle number in this case is 17. So this seems to be a better measure. It's not influenced by outliers such as the 53. A better measure, so median is a better measure when there is a very small sample group, and also in the situation where you have extreme numbers. So in my case here, we do have extreme numbers, that one there. So median can be a really useful statistic in a couple of situations, as I've explained. All right, I want to continue the discussion. I want to talk about this measure called standard deviation. Now, there are a number of measures that measure the range or spread of your data. Now, standard deviation is a specific measure, and I'm going to try to explain how it's created, but the main thing, I guess, in the end is to understand what it really means. So standard deviation, I'm just going to roll off the page here, comes out of what we call a frequency distribution graph. So frequency distribution is when you work out how many people you might have in each particular group. So you might have a table and you might kind of put your results a bit like this, and here is the the test condition, let's say it's height. And you've got a range and, I don't know, whatever, range 1, range 2, range 3. Range 1 is short, range 2 is medium, range 3 is tall. So this is your frequency. And here you might have 10 people, 50, and maybe another 10 there. So if I was to graph that on a frequency distribution table, I would have height 1, 2, and 3, goes up to 50, and my graph is going to look like this. And that's referred to as a normal graph. So the norm, the majority of people are in here. And this line down the middle that I'm dotting here, that is equivalent to the mean. So when I do my frequency distribution graph that I just drew for you with heights 1, 2, and 3, very simplified, and here's 10, 15, goes 10, 20, 30, 40, 50. We get this graph that looks like that. It's known as a normal curve. Okay, so a normal curve, let me make that a bit nicer, is used all the time, and in standardized testing we see it. So a bunch of people were tested, and then so if this graph that I'm showing you now, so if this graph here was no longer height, but was how many people completed an IQ test, we've got a bunch of people, most sort of centered around here, and this line represents the mean. So this is how standardized testing works. So now we have a normal curve, we compare all other results. So if you get a mark that's say around here, then you're above the normal, or if you or above the mean, or here, you're below the median, and that's how we work out IQ. We compare it to lots of other scores, and that's one of the features of standardized testing. Another feature, I should put that in, comparison on normal curve. That's how standardized testing is done. The second part is it's always run in the same way. Okay, finally to the last message, let's go back to our normal curve, and this could be for anything in particular. Now you can actually have a really very skinny normal curve, one where the majority of people are in around that area there. You can have a really wide normal curve, but they all center around the mean. Now, standard deviation is a measure of how far a score or a group of scores is from this mean line. So like I said, here's this mean line. So standard deviation is how far, how far the scores deviate from the mean. A high number, so if you compare, looking at a class set of, let's say we were looking at a class set of results from a test, and the mean result was, let's say, 25. The highest score was 50, and then the lowest score was 0, you've got a really broad standard deviation there. That means how a broad range of numbers from coming away from the mean. So a higher standard deviation means higher variation or greater spread from the mean. So let's look at a couple of classes here, Class A and Class B. Now you don't have to know how to work out standard deviation, but let's say Class A has a standard deviation of 8, but their median score, their mean score, was 25. And Class B's mean score was 25, but their standard deviation was 2. So I'll just put in that that's standard dev, and this is mean. Well, not going to do that. Not going to be able to write mean there. So what we do is, this is questions that will be asked of you in an examination or a test. So this score here means that the class scores vary, and I'll draw another graph. So this here represents the Class A, whereas this here represents Class B. So I better draw in our mean line. They both have a mean of 25, but Class A has a much greater variation of results than Class B. So standard deviation is a measure of variation from the mean. So STDEV is my shortening. Standard deviation is a measure of variation from the mean, and a high number such as this 8 with a mean of 25 is quite a large variation, and whereas 2 is not a large variation, meaning most scores were around that middle. Whereas with Class A, you had a lot more that were higher and a lot more that were lower than for Class B. I hope that helps.